Welcome back to Further Solutions Academy. Further Solutions Academy. Okay. I encourage us more to share the video if you have not shared before now. And just share across your friend. Subscribe if you have not subscribed before. This channel has a lot of videos for you to work with. A lot of videos, numerous videos. Just come here and come and learn any area of mathematics. On this video, I'll be working you on a summation notation. That's what we are working on. At this point, you should know what is called AP and GP, sequence and series. You know what is called series, you know what is called sequence, you know what is called, all those things in series and sequence. Now, when you talk about summation of notation, this is what we are talking about. It's a sign which this is how it always be. Most times, we call it summa notation. Summa notation. This is the summa notation. Now, it's not yet complete until I can say that, okay, let me just have I equals to M to what? To N. Now, it means I run from what? I to N. Let me have this as A of what? I. Now, that is what is called summa notation. Can you see how it looks like? It's very, very simple summa notation. Now, for me to notate this, it means I'm talking about it will be like this. LM1 AM plus AM plus 1 plus AM plus 2 plus AM plus 3 plus now plus AN. Now this is what upper band and the lower band. You can see now it's bounded below and above. Now it means it will start running from here to here. We make use of this summa notation under ODE, which is ordinary differential equation. You can see there on our channel. Now, if you have something like this, that is all. For example, if I write something like this, summa of what? I equals to 1 to what? 105. And I have I. Now, this is I. Now, it means what? I have 1 plus 2 plus 3 plus 4 plus dot. That is 105. That is what we are talking about. Now, that is what it means. It runs from this to what? To this. Now, another thing that can also come up, you can be asked to do something like this of I1 to what? To 11, and the I is on squared. Now, can you see this is equals to what I just need to do? I'm talking about what? I mean 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared plus to 11 squared. That is what we are talking about. I think by so doing that, you can see what we are trying to do. Now, with all what you are seeing now, that is what is called summa notation. There are some examples that you need to understand. Allow me to write something. Sorry, I'll make it to write. Okay. This could be a problem, that you will not be able to handle like that. For example, I have some questions there. Okay, now I'm asked to evaluate the given sums. Now we have this n to 3 and what to 7 of what? 5n minus 2. Now look at this. I'm asked to evaluate this. Now this is very simple. You just note that very simple. How do I solve this problem? Solution to this problem. What I just need to do is that I need to understand that my summa of n to 3, which is to 7. Now it will be, which is I have 5n minus 2 will be equals to 5 bracket of 3 minus 1 plus 5 bracket of 4 minus 2 plus 5 bracket of 5 minus 2 plus 5 bracket of 6 minus 2 plus 5 bracket of 7 minus 2. Now, can you see this one will be 15, 13, and I'll be having 13, I'll be having plus 18 plus 23 plus it will be 28 plus that will be 33. Now, when you add up this thing, it will give us 3, 4, 5. That will be 115. It means the summa of n to 3 to n of 5n minus 2 will give us this. That is the answer to that. Can you see how simple it is? Just note that when you do a summa, look at the lower and the upper, and you are running it up like that. Now, let me just move on to another problem, so that you can see a series of examples on this part. Another one can also come this way. You are asked to do summa like this of I equals to 1 to 6 I squared minus plus 1. Now this is also the same way we handle that one, but the only thing that is there is that this is powering what? This is square. Now solution to this problem, the same way we do it. Now what you just need to do, our summa of what? 1 to 6 will be equals to squared, which is I squared plus 1. Now what you just need to do, I'm talking about 1 squared plus 2 squared plus 2 plus 1 plus 3 squared plus 1 plus 4 squared plus 1 plus 5 squared plus 1 plus 6 squared plus 1. Can you see how it's being done? Now at this junction we'll be having which is equals to 2, sorry, let me first 1 plus 1 plus 4 plus 1 plus 9 plus 1 plus 16 plus 1 plus 25 plus 1 plus 36 plus 1. Now by doing this, I'll be having 2, 5, 10, 17, 26 and 37. Now can you see all what we are talking about? Now by so doing this, when I add up everything, it will give me 97. It means the summa of this to 1, which is to 6, of I squared plus 1 will surely give us this. Now can you see this is what is called summa notation. Now let me quickly, before I go to reduction of it, because I want to show you the mathematical induction part. Now let me try to explain the property of summation notation. Now let's talk about the property. Now the property of summa notation, I think let's talk about this. I think we find now talk about that. Now we'll talk about the properties of properties of notation. Now when we talk about property of summa notation, it's just like oh, you have been on integration, all those things. I think you should know that. Now when I have something like this, of it must run from I to n, and C of A of I. This thing can also be written as C of summa of what? Of N, and A of N1. Now, don't forget that this is a arbitrary constant, it's a constant anyway. You don't know what is called constant. Now, another thing you need to know that number one. Number two, we call it product property. Product property. Now, the next one is when I have something like this, and something like this is given to me from R to N of N, A of plus B of what? Of N. Now, when you are, I'm asked to do this, let me allow please plus or minus, because this will settle both notation. Now, it means this can be written as summa of what? Of N or to N, AI plus minus summa of what? Of N to N B of I. Now, that is what we are talking about. Now, these properties are very, very important because we'll be applying it to problems. I have some problems. Maybe in the next video I will show some problems from universities, so that we'll be able to see. Now, before I end this video, I want to show the implication of mathematical induction, because at this junction you have to understand what is called mathematical induction. Now, okay, look at this. Sorry, I won't be able to prove mathematical induction now, but I will just telling you that you need to understand it. You need to understand it. Now, let me just say by mathematical induction. Now, by mathematical induction, note that if I have number one, if I have of this of 1 to n of I, it always equals to in bracket of n plus 1 divided by 2. Please, I don't know how you're going to do this, because I won't prove it at this junction. If you want to learn mathematical induction, there are videos on mathematical induction on our channel. You can be on it. Now, number two, when I have something like this, summa of this 1 to n I squared. Now, can you see this one is normal I, this one is I squared. By mathematical induction, it means I'll be having n bracket of n plus 1, n plus 2 divided by what? 6. That is what n means by mathematical induction. Now, another thing you need to understand is that number 3, when I have summation of n IQ. Now, at this junction, this one will give us what? By induction, this squared bracket over n plus 1 squared divided by what? 4. That is what we need to understand. And before I leave this part of this, you need to understand some things now. Please take note of this information. They are very important. There are some problems that it will lead us to this. I will expecting next video I will work on it because of time. Now, I have this type of question. Look at this question was forwarded to me to our platform, and it says that I to 30 to 100 and of 4. Now, look at this question. Please take note of this particular problem. Now, it's a direct problem. Somebody asked you to work on this particular question. Now, this can be written as what? As 4. Listen to me. 4 of over I 1 towards to 71, which is going to be 4. Now, this itself, will give us 71. It means I'll be having 4 multiplied by 71. And 71 times it will be 28 and it will be 4. Now that is my answer. Please take note of that. Take note of that very well. That is the what is the answer. It was in 30 and 100. Now at this junction becoming what? 1, it means 1 to what? To we drop down. Now if I have another question, if question like this comes around you, take note of this. For instance, you have is a question from some past question which you need to understand it. Now, for me to work on this particular problem, what I just need to do, I will be having it will be equals to this will give me okay. Hope I'm not making a mistake. I'm not making a mistake. Now, okay. Oh, sorry. My mind was on you. Sorry, I made a mistake. There's a mistake I made. This is supposed to be 1. Thank you so much. Sorry, thank you so much. Now, at this junction, I will run to the property I mentioned earlier. It will be what? Of k equals to 1 to 100, 5k plus of what? Of equals to 100 and of 3. Now at this junction, what I just need to do is that I'll be having 5 of what? Of k equals to 1 and on 100 of k plus 3 equals to what? K to 1 of what? Of 100. Now of 1. Now look at this. I don't need to do any shifting because it's running from 1 to 100, 1 to 100, 1 to 100. This one was running from 30 to what? 100. That is why I need to do some drop down. Now at this junction, you know that this will give us what is there. Please take it of this. This will give us what is here, and it means I'll be having 5 bracket of that'll be k, that'll be 100 bracket of what? It means, let me use n. Sorry, permit me to use n. Okay. For us to understand it very well, permit me to use n. Permit me to use n. So that okay. N. Now, at this point, I'm talking about this. Now, it means n will be running from what? N. Now, at this junction, I'll be having 5 bracket of what? 100 plus 1 divided by what? Divided by 2. Close the brackets. Plus what? 3 multiplied by what? 100. 3 bracket of 100. Let me use 3 bracket of 100. Now, at this junction, I think I'll be here 1, here 50. Now, I think I'll be having 101. That'll be 250 plus bracket of what? 101. And this will be plus 300. Plus 300. Now, at this junction, I'll be having that'll be 200 and something. That'll be the answer will be equals to 2555. That is what we are talking about. Can you see how simple it is? Now, I'm trying to apply this, therefore I can't rub it up. Permit me to rub this side, please. Okay, look at another question. I was told to work on this particular problem. Before I end this video, let me end here. I was told to work on this question. I have summation of what? K equals to 1 and 100. Let me use n. Sorry, I would like to use n of 9k squared. Now, when you have this type of problem, it's very simple. What you just need to do, you'll be having, by the property, you can say that what? n to 1, and here will be 9, and here will be 100, and here will be k squared. And you all know that, sorry, n squared. Now, at this junction, this is going to be n. Now, at this junction, you know that this equals to this. It means I'll be having, I can use I will be fine for me, but anyhow I want to do it. Let me use I. Leave it at that case, sorry. Sorry for the stress. I don't want us to. That's how the question is being asked. Now, at this junction, it means I'm talking about 9 bracket of square would be n, that will be 100 bracket of 100 plus 1, 100 plus 2, divide 6, bracket of this. I think at this junction, I'll be having 9 bracket of 100 multiplied by 101 multiplied by 102 divided by what? Divided by 6. Now, at this junction, I can now multiply and do all sorts of things. By doing that by your calculator, by your machine, you will have, I think I wrote it here. Okay, 2218000. Now that is the answer. Now you can see, because of time, I won't be able to do further. But there are some problems that didn't drop through, I think, from the diploma student. Try to watch the next video for better understanding on this part. Don't forget to share this video and subscribe. Once again, thanks for watching.